Okay, here's some pictures we took during a maintenance outage of a coal-fired boiler. You can see down here you have the lower slope walls. Down here is the ash hoppers. You can barely see. Got a man door here. These are the burners. They're a low NOx burner where they stage the combustion to lower the combustion temperature and minimize NOx. Up here is the overfire air ports. These are used to control NOx. Here we have the division walls, otherwise known as platens, part of the superheater system. Some of these are 88 tubes across. They've installed different platens to increase efficiency. Some are 22. On site you can see some of the slag on the walls. I see a little bit of buildup around the burners. It's called an eyebrow. It can build up substantially. This one uses water cannons for cleaning the walls. There's a water cannon port here and then one up here. They'll shoot out a jet of water like a fire hose and hit the walls and try and knock the slag off. This looks pretty clean. Sometimes you have tube leaks, you'll get these little cones build up. These are old water cleaning cannons used to use before they got the water cannons. So these have been abandoned in place, and the cool air leaking in will cause a buildup of slag. Before you go in one of these boilers, they have to dynamite it, blast it, knock all the slag off. Up here, pretty much the division walls, the burners. There's 4 rows, 4 decks of burners, and there's 4 burners per deck. This just shows part of it. The slag falling down can damage your slope walls. I know they put crash bars on these tubes in the past. This is a membrane construction. You can see the water wall tubes, and between them they're welded metal strips. So it's a solid box. This is where most of the boiling of the water takes place. You got downcomers on the outside, bring water down, and then it feeds the bottom of these water wall tubes. Then it comes up to the steam drum and is collected up there. So this is the main part of the evaporator section of the boiler. It's a lot of infrared heat here. That's really the main part of this, is reclaiming the infrared heat from the combustion. Here's another picture of division walls. I can see some of the other smaller division walls in between them. You can see the overfire air ports, and you can see the burners coming across. It's about 60 feet from here to here. I can see some of the water wall tubes, a little bit of slag on them. They can get fairly substantial layers of slag on it when it's running. Another picture of division walls looking down on the burners. This is a smaller platen in here. You can see they have tubes go around down the outside of these to try to hold alignment on them. A big problem with this type of superheater, there's a certain load range where there's not enough steam flow to cool them versus the heat in the furnace. So we had limits to what range we could run. All these tubes are cooled by steam, so if you have to have a certain amount of steam flow to keep from damaging your tubes. This is part of the superheater section, first stage of it. Here we can see more division walls. They built the scaffold across them to do tube repair. Back here you can see the bowl nose in the firebox, and up here the superheater tubes. These are the finishing superheater tubes sitting down on top of the bowl nose. These will cover up with slag. You have to watch when you're running. You'll get kind of a white color, white shiny look when it starts building ash up across them. Like I say, the type of coal you're burning develops a lot of ash. You can plug superheaters fairly quickly. Here's a picture of the scaffolding, which was pretty amazing. They built this thing across. You're basically starting out with nothing. You have to go across and catch tubes and start building off of it. They use a sky climber system to inspect the boiler. It's cables hung down from the ceiling, and then they got a platform they'll use to inspect walls or fix tubes with. This is looking at the back side of the finishing superheater. This is the bowl nose. This is the finishing superheater. Above the bowl nose, your water wall tubes are stacked about 6 across backwise that allow passes for the flue gas. Underneath this, these are side by side, make a solid wall. Up here, they're stacked end to end to make a passage for the flue gas. So this is the back side of the finishing superheater. These are the water wall tubes. Here's another picture of the finishing superheater through two of the platens, and this is a smaller platen that's been added to the bottom of the bowl nose. And finishing superheat, this is where the flue gas leaves the boiler, goes through this passage. This is inside the bowl nose. This is collecting the feed water off the upper economizer. All the economizer tubes go here, then this goes out the boiler on both sides, and then it goes up to the steam drum. This is between the looking between the primary superheat and the reheater section. So right down here is your primary superheater. These are the tubes coming across the mix-up box on the back. You have two separate boxes. One's for reheat, one's for primary superheat and economizer. The finishing superheat's back on this side of it. Here's another picture of that area. These are the water wall tubes that are spread apart to allow flue gas to come through. This is your primary superheater. You can see some of the ash buildup on the tubes. There's soot blowers. I'll go through here and try and knock it down, but there usually is quite a lot of ash buildup. There's a passage in here that goes back to the reheater section. These are the tubes that make up the primary superheat box and the reheater box. You can see more ash buildup on the tubes. This is the kind of same pictures walk through here. You go through these tubes and it's kind of, you can go to the bowl nose and then out to the finishing superheat. Another picture of the finishing superheater and the water wall tubes. You can see down here where it makes top of the bowl nose. These tubes make a solid wall. Then here they're bent in to allow passage for the flue gas. Got a safety cable along. This is between the primary superheater and back the reheat section. They're doing similar. They have the walls make up the separate compartments for the primary superheat and the reheater. The tubes here are back to back to allow flue gas to go through. Big problem with the primary superheat on this here, this ash will actually build all the way across here and start plugging this up. So you got to watch the DPs across it, the type of coal you're burning. Too low of oxygen levels will promote more slag. We have had major problems with this plugging up, and then all your flue gas has to go down the reheat section. It drives the reheat very high and it's uncontrollable. During outages, they'll come in here and use Primacord, dynamite, and blast all this, knock all the slag out. Hard to believe you use dynamite in boilers, but it's about the only way to knock the slag out. This is back the reheater box. These are the reheater tubes. There's a lot of sections of this. I don't know, it's like 43,000 square feet of tube or something back here. This would be the steam coming from the HP turbine exhaust. It's heated up and then it goes to the IP turbine. Heats about 1,005. All this tubing's rated for about 1,005 degrees, which means it's probably 2 1/4 nickel up here. And lower temperatures, it can be 1 1/4. These are the dampers underneath the primary superheat and the reheater box. This is what controls the temperature. You'll vary the flow gas, the flow of the gas through here to control your temperatures. This will be the primary superheat temperature. This is the reheat temperature. Your primary economizer sits right above these dampers. This is an economizer ash hopper. This sits on the back of those, underneath those dampers. As the soot blowers run, they knock the ash off the tubes and it drops down to here. I can see one of the burner decks is starting to get where the burners are. So that you have to run the soot blowers continuous to keep the slag off the tubes. Now the pulverized coal, the little particles that there's ash and stuff in it. This is some economizer ash. It makes kind of a really porous material that it's kind of crumbly. This is cinder grinder. Underneath that hopper, your economizer ash comes down and it's ground up. Probably ½ inch, ¼ inch size. Then it uses air pressure to blow it out to a silo. So this is a little feeder. Basically, ash fills this up. Then from here is you pneumatically transported outside. You can see part of the burner deck. This is the burner deck. This is a pulverized coal burner. There's 4 of them on a deck, like 20-inch pipe. There's a close-up of the burner. This is where the coal is coming in, coal-air mixture. It's primary air coming out of the pulverizers. Up here we have a sleeve damper. This is used to control the amount of air, secondary air fed in with the fire. There's various adjustments that were set to control the NOx on these burners. They stage the combustion to lower the temperature so you don't get the high NOx levels. Here's your igniter. Uses diesel oil. Burns about 3 gallons a minute. I use it as a sparker. There's cooling air. I don't see any flame scanners right on this picture. Here's your igniter, little sparker that lights the fuel. This cylinder goes in, shoves in the igniter and the burner and lights it. Once you have all your igniters going, then you can start feeding coal in. There's flame scanners that look at the igniter and also the main coal flame. Here's a video of the actual burner inside the boiler. It's pretty violent in there. I can see an eyebrow forming up here just from the pulverized coal. You can see air sucking in there. It's a minus 0.5 inches water column, so it's pulling in dirt and stuff. You have to use at least a number 5 shade to look in there, and gloves. It's pretty intense heat. Because most of your heat in there is radiant heat it's picking up. Here's just a picture looking at the porthole. That's kind of what it looks like. It's pretty bright white. There's somebody looking in the boiler. You have to look for slag builds up, conditions of burners, various things, but you do have a face shield on. This is looking through that number 5 shade. These are the finishing superheat tubes. They will get this white slag buildup. So I can tell you have a buildup problem. It'll be a white slag. It'll start forming across here in big patches. When that happens, you really have to hit the soot blowing hard on it. Try and knock it off. Another view, that's about what it looks like looking at there without no protective goggles on. Here's a picture of a soot blower. This is one of the bigger ones, and this would be hitting that finishing superheater. You can see the carriage is driving in, it rotates it. This is feeding steam in. This shaft here is feeding steam and it's driving in here. I think it's about 16,000 pounds an hour of steam. Runs about 300 psi. Big problem with these soot blowers, the lances will bend. If they don't have steam flow, they'll bend really quickly in the heat of the firebox. So you have to keep them rotating. They drive in, and the steam's really the cooling media. In time, they will bend. If they jam in there, you can use a pneumatic wrench on the back of these and try to back them out. It has a track up here with little gears that drive it in. So it's actually track driven. There's packing on the end of it here. It'll start blowing a lot of steam when it starts giving out. These are self-adjusting packing. The other soot blowers you have to adjust them manually. This thing here is carrying down the wires and control to the carriage. It's making sure that it's turning and traveling. There's two motors on this. One's turning it and one's driving it in. This is actually a smart soot blower. You can set these up to drive in so far, stop, and then turn, partial rotation to clean a tube, then go back in and clean more tubes. This is just driving straight in. These are catching the division wall and the soot blowing, so they're a pretty major soot blower. Here's another picture of the other style soot blower. Here's the lance. You can just see where it spirals in. That's how much it moves about every turn going in. They have a support structure here that supports the lance. When the carriage comes by, it drops down and lets the carriage go in. You're blowing soot all the time. Soot blowing is pretty critical on this type of boiler. Pulverized coal, you got 5% ash or so, and it's melted. Depends on the type of coal, how bad your ash problems are going to be, your slagging and temperature. But soot blowing is critical. Picture of another soot blower. That's the steam line coming up. You can see the feed tube, and here's the carriage. These rollers, they support the carriage, and there's a little drive-in behind it. They go in about 30 feet or so. You have to worry about these getting bent and hitting stuff inside the boiler. They're going through a fairly small passage between tubes. They can crash, hit a tube when they bend, or even coming across two of them run at the exact same time. They could hit, which is pretty rare. This is a soot blowing lance. You can see they're about 30 feet long. Here's the end of it. That's where the steam comes out. There's another hole on the other side to kind of balance it. Here's the other side of it. So they're throwing a lot of steam out. This one of your major makeup water uses is soot blowing. This steam here goes out the stack. This is a water cannon. It basically has a nozzle jet of water, and it has an X and a Y drive axis, so it moves it. It's set to a pre-programmed location, so it'll clean a certain part of the boiler. You'll drive the nozzle to where it needs to be, then it turns the water on, and then it moves and cleans that part of the boiler. We have 4 of them. Used to have a lot of little water cannons along the side, but these 4 do a pretty good job. This is an acoustic detector. It looks for high frequency noise for finding tube links. These will pick up noise that your ears will not pick up. So if you have a tube leak, it'll show up on one of these. Also, when a soot blower runs, you'll pick that up, so they come in an alarm. This is the feed water going in the boiler. This is the lower economizer back here. I can see they got some O2 probes along here. There's a lot of O2 probes across this boiler on the bottom and top. That's where you're looking for getting efficiency with combustion. But this is your main feed water going to the lower economizer. Line comes out, then it goes up to the upper economizer, and then from there it goes up to the steam drum. This is the division wall spray. There's 2 sets of temperators. They're controlling the temperature down about 860 degrees. This is coming out of the primary superheater. You spray it down to about 860, and it feeds the division walls. From the division walls, it's sprayed again to maintain 1005 degrees on the finishing superheater. These kind of boilers, you have radiant heat and convective heat sections, so they kind of balance out with different loads. Both these valves are used together to control the temperature. We call them sprays, but people call them temperators. You're using boiler feed water to spray down with. There's a separate stage on the feed pump that puts out higher pressure than the steam for the sprays. You have these and the finishing superheat both come off of a higher pressure part of the feed pump. This is the steam drum. Here's the feed water coming in. There's a chemical line coming in. The other side had the continuous blowdown. This part of the level. These are the pressure transmitters for the drum. Level transmitters set down a deck below. These are the safeties on the steam drum. There's 3 on each side of the steam drum. These back here is the steam coming out of the boiler, your main steam lines. These 2 safeties are set at a lower pressure, so if you do get high pressure, these relieve first to maintain steam flow through the boiler passes. You don't have steam flow through tubes, you can do damage to them fairly quickly. This also has an electromatic relief valve where you can manually open it to dump pressure. But these are the 2 steam lines coming out of the finishing superheater. They tie together to one line further down. These are the downcomers. This is the water coming out of the steam drum. It's going down to the bottom of the boiler to feed the water walls. This is inside the penthouse. This is the support structure for the water walls. The whole boiler is hung from this frame. So all the weight of the water walls go through these hangers, and then they're secured to a beam on top. You can see part of the division wall piping in here. These are the roof tubes of the boiler. Steam drum sits back in here. It feeds this header. All these tubes here go back and they make up the top part of the boiler roof. These tubes from here will continue back and make the boxes that feed the primary and the reheater boxes for cooling. So this is kind of this is the first stage of superheat. Saturated steam comes out, it feeds through these, it's heated, and it goes through the primary superheat. These are the division walls. These are the platens they've added since construction. Just another picture of the hangers of the water wall. Back here shows the roof tubes. These are the division walls up here. This is up in the penthouse of the boiler. This is on top of the boiler. This is the roof of the boiler inside. Steam drum, I say, sits back in here. Another picture of the division walls. This shows some of the support structure. These are supporting the water walls. You can see the roof tubes are supported here. Division walls are supported. So the whole boiler is hung from the ceiling. That way it expands. It'll expand about 11.5 inches as it's heated up. These are the finishing superheater headers up in the penthouse. Finishing superheater sits down underneath this through the walls. This is the inlet coming off the division walls. Back here is the outlet going to your main steam outlet line. They're insulated back there. As you can see, there's a lot of tubes, a lot of bending. It's a pretty complex item. This just shows one of the IK soot blowers. Here you have the acoustic detector. It's kind of dark. It has a ring here with the rollers that supports the weight of the lance as it goes into the boiler. And that's it.